Hi, our project is a Kubernetes-based on-demand research computing environment on the MOC, and mentor is Mike Rickey from Harvard. Our project is significantly surrounded with a research tool called SEED. So what is SEED? Developed by the Harvard MIT data center team, SEED is a research tool runs on the cloud that allows researchers and scientists to launch scientific computing environment to analyze research data. On the SEED environment, users can launch instances of Jupyter Notebook, RStudio, and Linux Desktop as interactive apps in containers. This is the web interface of SEED. As you can see, users can select an application, for example, the Jupyter Notebook, and authorize Google Drive, which is optional, then select the CPU and RAM requirements to launch the application. Currently, SEED's backend container infrastructure is powered by Amazon Elastic Kubernetes Service, which runs on AWS Cloud. The final goal of this project is to move SEED backend container infrastructure to Massachusetts Open Cloud, or OpenStack, since the MOC environment is built on OpenStack. In other words, we will replicate the functionalities of Amazon EKS by developing a pure Kubernetes cluster on OpenStack VMs. As a project mainly working on backend, the active users are the technicians of SEED. SEED's administrators and developers should eventually know how to deploy the same SEED computing environment on MOC with Kubernetes as on AWS. It does not target SEED end users like researchers and scientists who wish to utilize cloud computing environment simply via the SEED interface without knowing which cloud platform is on.
Let's talk something about the technology we use in this project. The first is OpenStack. OpenStack is an open source platform that uses pooled virtual resources to build and manage clouds. In this project, the OpenStack offers access to virtual machines on clouds.
We talk about OpenShift. We're using OpenShift in our project. So OpenShift is a containerization software that is developed by Red Hat. The OpenShift container platform is a platform as a service tool built around Docker containers, which allows us to build cloud-native applications. It is managed by Kubernetes. So we use this to deploy our front end on the OpenStack. Next.
Kubernetes is an open source system that allows organizations to deploy and manage containerized applications. And in this project, the SEEDs, we can install SEED on Kubernetes pods and run SEED on Kubernetes. These figures show the functionality of OpenStack and Kubernetes in our project. You can see the OpenStack manages many virtual machines, and we deployed Kubernetes on each of these machines. And each Kubernetes has many paths, and SEED can work in these paths.
Okay, another tool we use is a Terraform. So Terraform is an infrastructure as code software tool by HashiCorp. And this can be used for building, changing, and versioning of our infrastructure. So basically, we are using Terraform in our project to spin up the instances, to configure our networks and routers, and to create security groups and key pairs. Next. So the advantages which we got for using it were that we could automatically provision and deploy the VMs just by running the script. The complex chain sets that we required that can be applied to the infrastructure with minimal human interaction, and reusing the infrastructure and sharing it with ease. Next.
After we deploy the virtual machines, what else we want to do is to make the process of deploy Kubernetes on virtual machines automatic. And that's why we use Ansible and Kubespray. Ansible is a configuration management platform that automates storage, server, and networking. And kubespray is a composition of Ansible that aim to deploy Kubernetes on cloud. And we use Ansible scripts to install Kubernetes and stand up the clusters on OpenStack virtual machines. All we need to do is connect to the virtual machine, configure cluster variables, and run Ansible, and then you can automatically deploy Kubernetes on the virtual machine.
So we use these tools to recreate and deploy SID on the MOC. To do that, we split the architecture into two main pieces. That's the front end and middleware and back end piece. The front end and middleware utilizes Terraform's Kubernetes provider to access OpenShift's underlying API. Our solution deploys 4 containers in one pod. This is to combine their networking, and it required containerizing 2 of SID's original components. The backend utilizes Terraform's OpenStack provider to access OpenStack's underlying API to create VMs and other resources. A precursor to deploying is an Ansible playbook that utilizes kubespray to deploy the Kubernetes cluster. So here you can see the SID architecture, and on the left here in red is the front end and middleware section where we deploy on OpenShift. On the right, you can see the backend Kubernetes cluster, which is deployed on OpenStack. The automation aspect of this is they're both using Terraform to handle the deployments. The front end section uses Terraform's Terraform's Kubernetes provider, while the backend uses Terraform's OpenStack provider. Ansible is a precursor to building the backend, and Docker is a precursor to deploying the front end, as you need to containerize those 2 images and upload them to the MOC's Docker registry.
Okay, here is our sprint plans. In our first sprint, at the beginning of the semester, our teams try to get familiar with the system tools and environments, which includes many different terminologies and as well as the architecture of the software. Then, in the second sprint, our team set up a local development environment on our own system, and also try to build a tool to test the Kubernetes backend directly without the front end. In the third sprint, basically we prepared for the SAC papers presentation and gave the lecture to the class. In the sprint 4, what we did is using Terraform to create resources on MOC and manually installed Kubernetes on MOC. Then sprint 5, we finished up the deploying containerized front end on OpenShift, and as well, we used kubespray to automatically deploy Kubernetes on MOC VMs. In the last sprint, sprint 6, we finalized the project. As our mentor mentioned and required, the most important part of this project is collecting our knowledge and hand it to the next team. Then the next team who will work on this can get a big benefit from our works. So in the last sprint, we mainly focused on the documentation part. We wrote a documentation to guide the others on how to use our scripts to create resources, deploy Kubernetes, and containerize the front ends. As well, we wrote the documentation about how to change the configuration of those automation process, and as well the reason why we are choosing to use the tools that we mentioned before. Besides that, we also fixed some bugs and rerun the scripts from scratch to ensure others can reproduce our workflow in their own system.
Okay, so here we demonstrate the live demo for our automation scripts. So I'll first talk about the backend. As you can see, initially we have only 6 instances on the left here, and our goal is to deploy 3 more VMs, which consists of a bastion server, a master node server, and a slave node server. before we run Terraform, we actually need to configure our variables file, which contain all the information about what we want. For example, how many Bastion, master node, and slave VMs do we want? What flavor of the VMs do we want to create? Authentication information, and so forth. To actually kickstart the whole automation process, we run 3 different Terraform scripts shown on the right. Basically, Terraform init is used to install all the required plugins. Terraform plan on the second bullet point is used to create execution plan. Basically, it tries to figure out what configuration files needs to be correct and tries to check for any potential error before we actually execute the plan. Lastly, the Terraform apply command is used to apply the change required to reach the desired state as listed or mentioned in our configuration file. So I'll play the video. So as you can see, we first enter Terraform init, and then we enter Terraform plan, where it checks the error. Yeah, and then we enter Terraform apply. So Terraform apply is going to take a while, so we can jump right to the end. Basically, it shows us a message and it's done. After we execute the Terraform scripts, we have created 3 new VMs. Previously there were 6, now there's 9. And to make it simple, I actually skip some of the details. Under the hood, floating IP, security groups, and other resources are generated as well and used in the process to make this possible. We can also ping the backend just to make sure that these VMs are alive. This is the network topology of the new instances created. But we have not deployed Kubernetes onto our VMs yet. So the next part is to deploy Kubernetes through KubeSpray. What I'm going to show here is actually a speed up version because it actually takes 20 minutes approximately to run the whole thing. So KubeSpray is really a cluster of Ansible scripts. And so we really just need to run this command. It basically starts the whole Ansible playbook. And the cluster YAML is the Ansible configuration file to state which kind of test or installation do we want to run. After the installation is completed, we can access. In my opinion, in my case, I SSH to the machine to make sure that the kube ADM is installed properly. So let's say we're done and we want to tear down the whole thing. We can also use Terraform destroy, which would basically remove all the resources that we have just created. So I'm going to skip to the end. So here it says that's destroyed. And then we're back to having 6 VMs, which is what we started with.
So now I'll talk a little bit about deploying the SID frontend. As I mentioned before, the front end is deployed using OpenShift. And to do this, we sectioned it off into 4 main parts. There is the HTTP server, where the user interacts with the service. There's the Redis queue, a MongoDB server, and another JavaScript node server that handles Redis queue jobs. So here's a little bit more about that. There's 1 pod with 4 containers on OpenShift. That's the MongoDB, Redis, and 2 nodes. The reason we deploy under 1 pod is so all of these can talk to each other under a local network. To deploy this, we used Terraform, and this would allow us to bring the service up and down and also scale it. The Kubernetes provider is used to control the OpenShift deployment. This is because there is no Terraform OpenShift provider. So OpenShift runs on the Kubernetes API, so instead we can just use that. To containerize the 2 nodes that needed to be built, we used Docker, and those needed to be built, tagged, and pushed to the OpenShift registry before the building process can be done. And here is a quick demo of that. Here you can see I'm doing Terraform apply to build. You can see it immediately starts building three pods with 4 containers in each. And then the terraform destroy will immediately start bringing that back down. And it is gone.